Next part of this chapter deals with reciprocal graphs. Reciprocal graphs are really weird looking graphs, and it's best that you just memorise the general shapes of reciprocal graphs. Just stick them on a flashcard and memorise what they look like. So I'm going to start off with, say, what does y equals 1 over x look like? Well, it looks like this. It's asymptotic to the x and y axes, so it never quite reaches the y axis, never quite reaches the x axis. Well, what about if it was, say, 2 over x? Well, 2 over x would just take a little bit longer to get to the axes. So it just flattens it out a little bit. So that one would be 2 over x. But in general, they look pretty similar. What about if it's negative? So say y equals minus 1 over x. If it's minus 1 over x, then it simply looks like this. I mean, if you're, in the exam and you're under pressure and you're not sure and can't remember, just plot a few points or use the table function on your calculator. Or if you're really hopeless at graphs, buy a graphics calculator and just smack it in. What about 1 over x squared? What would that look like? Well, 1 over x squared starts off looking like that. But remember, the property of x squared is that when you square anything, it's positive. So was it looking like that too? And what about minus 1 over x squared? Well, very similar, but upside down. So those are 4 base graphs that you really need to memorise. So example 5. I've got to sketch the graphs of 4 over x and 12 over x. Well, they're both examples of this. So if we say this is 4 over x, 12 over x is just further away. B, minus 1 over x and minus 3 over x. Again, it's going to be examples of this. But they won't ever reach the axes. So say that's minus 1 over x, minus 3 over x just takes a little bit longer to get to the axes. It's just less steep there. Say 4 over x squared, 10 over x squared. Some examples of this. You see, it looks very similar to this. Because unless you've got another one, there's no comparison to make, so it depends on your scale and your axes. So 10 over x squared would just be a little bit further away, take a little bit longer to get to the axes. Right, that was the only example before exercise 4C.